Okay. So yesterday we discussed about Spark architecture, its key feature, and how it is working, what it is actually, why we are using it. Correct. So here, just I have created this to make understanding at high level, and again in next session I will elaborate it more with more details with the example that how it is really working. So as of now, take it as an overview. Here you can see this is cluster. What is cluster? Cluster is a group of machines, right? So here you can understand that I have taken 10 machines. You can say 10 laptop, 10 computer, CPUs, its RAM and all. So this is the 10 machine. 9 machine I am considering that these are the worker node. Worker node 1, 2, 3, and accordingly worker node 9. So total worker node 9 are there, and out of 10 machine, one machine I have considered as master node. To master node we have driver program, that is to manage the entire application which is running over the executors worker nodes. This driver node is connected with each of the executor, each of the worker node, like 1 2 3 4 up to 9, whatever. What is the size of cluster? This is integrated with all. This is having connectivity with all the nodes. So you are having some group of machines. One is treating as getting treated as master driver, which is responsible for handling all the things as a driver program, and remaining all are working as a worker node. Then we have cluster manager. Cluster manager is for resource management, which is responsible for what to do, how to do, and where to do. This is taking care of all the things because these are just a simple machine. They need some instruction, then only they can work on. Here I have, you can see this is for the driver program I have mentioned here. Here these are the executors. Over executors, there will be tasks running. So we will discuss that later when we are going to do with some program, and by that program we can try to understand how that is really getting distributed and how that is working. As of now, you can take it as high level. And over this driver program, here I have mentioned the Spark context. Spark context, that means that is the entry point for any of the Spark application. If you have application, for each of the application, there will be a Spark context. And now it is Spark session. So previously, Spark context, SQL context, and Hive context was a separate one, which we had to create. And using Spark context, our program was getting initiated. Now we have a Spark session, and the Spark session is the bind of all. Using the Spark session itself, you can initiate context, SQL context, Spark context, Hive context, and all. So you can take that reference. So this is here over the driver program. And the same Spark context or Spark session will be available for all of the worker nodes. Let's say you are working with a task, and that task is available to n number of worker node, either 1, 2, or maybe all. So the same Spark context or same Spark session will be available to all. It is not like that for everyone. There will be different.
It's
Okay.
Alana because
Yes.
just so also previously I also just read from my end. So exactly what is the difference between Spark context and Spark session? So these are different. Na?
What is your understanding? Tell me.
I know that previously for RDD to create a RDD we need Spark context. Now suppose if you are dealing with data frames and all, then the Spark session concept come. But we need both. Suppose something like we need to view some internet details also. I think we need Spark context for that.
Correct. So see, this Spark session was introduced in Spark 2.0. Okay. Currently we are with 3.5, 3.5 point something. That will be always something. So for this, we had a Spark context, SQL context, and Hive context. It was a separate context. Now, coming to difference between this, both are having different context. Okay, first we are talking about the Spark context, then Spark context is a core of Spark cluster management and the entry point for interacting the Spark functionality version prior to 2.0. Now we are we will discuss about that as well. The main purpose for the Spark context whenever we are creating managing the connection. So as of now we are not going to manage the connection. And before if I'm looking to this cluster and I'm talking about core Spark context, not Spark session and all, then we need to create the Spark context that is responsible for running any of the application, and we can utilize that. Now, if you are working with RDD, okay, for RDD, for some of the transformations, Spark context is still required. So this is used for all of the Spark operations. And it is mostly it is getting it for simplified, and we as of now we use it only if we need low level access to RDDs or backward compatibilities, which is with 1.0 means prior to 2.0. Let's say Spark is having some 100 plus of functionalities. Some functionalities are enhanced and that are supporting with the high level. Some are some functionalities are which were introduced prior to 2.0, and anyways any functionality which was introduced either prior or later, that is supporting everywhere with all the things. But some transformations, some APIs are still there which is still working with the low level API, that is not getting upgraded, or maybe that is not required as well. So Spark context as of now, this is used only for the low level access to RDDs. For some of the transformation or backward compatibility, that is not up to date with 2.0. Otherwise, Spark context is not required. And Spark session is everywhere required. If you have a Spark session, nothing is required. This will be working for each and everything. Even from Spark session itself, you can take a Spark context. Okay. So this is the Spark context, and this is the cluster manager. Here I have taken yarn. You can take any of the resource manager. This is just alternate. You can have Kubernetes, you can have Mesos or something else. Here let's consider that it is yarn, and this is the cluster manager. This is your driver program which is having a Spark context, and cluster manager means this yarn is for processing, right? So this is having two terms again. One, you understand that in cluster you have master and slave. So this driver is master, remaining all executors are slave. Now this yarn is also having master slave concept. So here I have mentioned resource manager. This resource manager is acting as master, and these are the node manager. Node managers are for as a slave, you can say. For the resource manager is going to direct, going to instruct, and accordingly node managers are going to perform the activity. Now you assume that this is a developer and the developer is trying to fire up Spark submit command. Using that Spark submit command, trying to run application. Then this Spark submit command request goes to the resource manager, whatever it is, either it is yarn, Mesos or something else. And that request is going via cluster manager. And from there, actually initiation happen for any of the application. That how it has to work. Because this is just a cluster, nothing is there. This is just a cluster which is having all the installed with the like we can consider this is the master node, this is the driver node, this is worker node which is having the executors. We have yarn as a resource manager, and yarn is having parent and child means master and slave, that is a resource manager and node manager. Now when you are trying to submit, then this user is giving some information as well for submitting the application. So let's consider this cluster setup, what it is and how it is, what is available with it. So here I have mentioned just for the assumption, this is the cluster config. You assume that 20 core per machine means a CPU. So you are having total 10 machines. So you will be having total 20 into 10 equal to 200 cores. Okay. Then consider that it is each machine is having 100 GB RAM. So 100 GB RAM means total it will be 100 GB into 10 equal to around 1 terabyte. 1 terabyte RAM. Okay. It is around 1 terabyte RAM. So this is the cluster config. Now this user is trying to fire a Spark submit, and here I have mentioned, just I will maximize it, or let me copy this. It is not okay. Here you can see we have to provide the class and then master. What is the master? About the master, then deploy mode, cluster or client, we will discuss it. Driver memory. Let's say user is looking for 6 GB driver memory, executor memory, something. Let's say here it is 18 GB. Number of executor I am asking for 5, and executor course I am asking for 5 again. Then what is available? Here it is having availability for 20 cores. I am looking for 5 only. Then it can get allocated from anywhere. I am looking for 5 executors. So it is having total 9 executors. This resource manager can allocate any of the 5. And then with that 5, any of the 5 core from that machine. Now, if we look about the memory total 100 GB RAM is there. We are looking for few 6 GB for a driver and 18 GB for the executor. So this can take any of the machines for the master, for the driver, and for the executor nodes, and allocating that memory. And remaining memory will be still available there because total memory is as of now 1 terabyte for this small cluster. We are asking for the allocation on 18 GB and 6 GB. So remaining memory can be utilized for the another application which is running over the same network, same cluster. Okay, so at a time we can have parallelly multiple applications running separately, independently, without any conflict with anyone. So this is the cluster manager. Cluster manager will be having connectivity with all. Here I have made this arrow with all only 3, but to assume that this is having connectivity with all these 9 worker nodes. So this is how they are getting connected with each other. They are linked. They are having the communication where cluster manager is working as a mediator for application deployments and all, because developer is not going to communicate with the driver and not going to communicate with the executors directly. This is going to communicate with the cluster manager, and cluster manager is dealing between driver and executors. And then tasks are getting deployed and it is getting working. Now how tasks are getting deployed? Like when we are firing the query, when developer is firing the query, this is going to create the tag. Inside tag there will be stages. Inside the stages there will be task, that is the smallest unit of the work, and then that will be getting done by the JVM, where application master is going to create, that is going to create a container. Inside the container your application will be launched, it will be completed, then history server is going to maintain, and then finally this is going to produce the output. So that we will be taking up later with the same diagram with some example. Okay. It is okay, or any confusion, anything?
Hmm.
If not okay, please let me know. May I know who is this guest user? Okay, I think someone is there, but you can rename yourself. Fine. It is okay. Anyone? Niharika? Kshitij?
Yeah.
Okay, fine then. Anyways, we will take one of the example, a small example with the small code, and then we will see how this is going to create the tags and the staging, and then this is going to deploy the tasks over the executors, and how this is completing the entire application. Okay. But this is just an overview for the cluster where how this is going to work internally, how this is getting treated for the any of the application where a group of machines are there, and that is considered as the cluster. And with that cluster we are going to work with our application in distributed mode, because here we have 9 machines. So if we have, let's say, 9 GB of task is there, so if driver program is going to work, let's assume that this is an independent machine, independent cluster, just like our traditional model, traditional database, let's say. So if this is working alone with 9 GB, then of course this is going to take time. And here, as we have 9 separate machines, including this, we have 10. So if we are going to work in the distributed manner, if I have 5 GB, 6 GB, 9 GB, whatever memory, if we just distribute between the machines, then workload will be reduced for everyone, and they will be faster to complete the task. So like that, this is going to work in the distributed model. Now we'll be back to this document. I hope that you people are having the setup for Spark. If not, then you can, as of now, for starting purpose, you can go ahead with Databricks community. So here I have this. This is expired for me. Okay, as of now I do not need it, but you can do the login. Okay, Databricks community version is there. You can take this. I will just ping it and you can try it out. If you have not registered already, then you can register and then you can create the notebook. Okay. I think Databricks community. Okay. So now let me go. So yeah, either you do the setup or you can go for IJF now Databricks community and you can do the hands-on. Like here, if you see, let me do that. So, let me quickly log in. Set. I had to Databricks community. Okay. So here we can, I have to create a new notebook we can take, and we can even rename it. Spark Learning. And then here we have to take the cluster resources. This is one node cluster which is available for free. You can select the version as well from here. Okay, I am going with the default one, create, attach and run. And once this is available, we can run the Spark job. You can try out with the queries and all once this is available for you. So I will quickly run one, then we'll move ahead. I will take the Spark session from here. Import anyways in Databricks Spark session is not required. Okay, because this is internally this is developed for mostly for Spark only. This is for Spark purpose and this is optimized a lot and it is as it is dedicated for Spark. Spark session is by default available and this is too much optimized. If you are comparing with any of the other platforms for the Spark queries, this will be always faster and it will be resulting much better output. Performance level, not other level, because logics, codings, and everything is same only. So, but
yeah,
here for the
code, I think his screen is stuck.
sorry,
You have already running some code or just
no, I am not running. I was creating the cluster. Now this
okay.
is available. So this month I was saying that this Spark session is actually not required in Databricks. But if I am running with local, let's say here I have set up in my local. In local, this is required because without the Spark session, we can't do anything. This is the entry point, so this is required. In Databricks community, and not only community, anywhere, this is not required. This is by default available. Now, if you want to test this, you can simply do test df test df equal to spark.sql select one and then testdf dot show. Let's run this. This is working fine. We are good to get the data frame and tabular model right for this select one. Now, if you want to create the RDDs and all RDD data frame data sets, we all we can create. So we will go ahead later. Just let me go here. Okay, so Spark is having these modules: Spark Core, Spark SQL, Spark Streaming, Spark MLib for machine learning, and graphics for graph queries. These are for available by default, which we can use as per our requirement, and we can run with any of the uh, platform with R, Python, Scala, Java, or maybe SQL. Where if we talk about Spark Core, then Spark Core is the main library of Spark, which provides the abstraction of how distributed task dispatching, scheduling, basic input and output functionalities internally, how this is getting dealt, everything. Then Spark Session. Spark Session introduced in version 2.0 is an entry point to underlying Spark functionality order to programmatically use Spark RDD or DataFrame or datasets. Also, we should always have a singleton Spark session only. If you are getting multiple Spark session inside the same application, you will be getting error, and that error will be most of the time it will not indicating directly that you have more than one Spark session. Your error can be of different type, and that will be because of a Spark session. Root cause will be Spark session, so that will be creating issues for you. So better have a singleton Spark session, and wherever you need in with your entire application, just get from that class only. Wherever you have created it, get from there instead of having a new instance for the session. So this is going to support you as an entry point either in the RDD, data frame, or data set, and its subject to Spark is default available in the Spark shell. If you are working with the Spark shell with any of the VMs or maybe some other system with the on-premise or cloud system, Creating a Spark session instance would be the first statement, and we are going to write the program with any of the APIs with RDD data frame and datasets, where a Spark session will be created using a Spark session dot builder pattern. Here, if you come and you can see this is dot builder. Using this, it is creating a Spark session. This app name. This is mandatory or this is default. Anyone can tell me? Let me run this, then see. Then also this is working, right? This did not get fail. That means this Spark session, this is the one which we are importing from Spark by Spark.sql. A builder is required for building the Spark session. Another things are not required. Get or create is required. So we can do without that as well, but I am giving here is app name, because if you are not giving the app name, this will be having the default app name. And if you have multiple applications running, you will struggling to find out which application is for my job. And then further you are going to debug that, or you're going to monitor that. So if you have a name, proper name, then you can quickly find out and you can directly start your monitoring, debugging, whatever you are looking for. So better to have this app name, but not mandatory. It's optional. Now get or create. What is get or create? Anyone is having any idea?
So if there is existing, then it will get, or it will create.
Right. So if any Spark session instance is already available, then it will get. If not available, in that case, it will create the Spark session. If you go internally to see the implementation, how it is, then you will be having more clarity. If you don't want to go that much deep, then just understand that a Spark session is required. That is the entry point for any of the application. Without this Spark session, we cannot start with the application. It is not going to work for us. Okay. And here builder and getter create is a
Anamika,
mandatory one. Yes.
for this Spark session only we are creating for this specifically application name, or it is it's a common one and we can create multiple
No.
application within the one
No.
session.
So let's say I am having a program. I am reading JSON. Okay. And I am reading JSON file and writing output to database. This is one of the requirement. I am working there. Now you are working, reading the same JSON, reading same JSON, writing to Kafka topic. Now we are working with two different applications, right? In that case, for this Spark session will be different. For this Spark session will be different. And app name also, I can give a JSON to DB, and I am going to monitor with that. Okay. And you can give JSON to Kafka. That is for your reference. So both will be completely independent. There is no connect unless those are inside the same application. If those are part of same application, let's say in the same code base, we are reading and we are writing to database also, and parallelly we are writing to Kafka topic also. If same application, then single Spark session will be there. If different application, if we are firing Spark submit one, if that is going for from Spark submit, this is Spark submit one, and down one is with the Spark submit 2. So for each of the Spark submit, there will be separate sessions, and each session can have either same name or different name, doesn't matter. You can have same name also, but same name we do not keep, because again you will get confused, right? Which one is yours, which one you need to look into. So better to have a unique name.
Or any other default timing for a particular session.
Sorry.
When we create a session for any application, so is there any specific time for the session to expire,
No,
or
no. It will be available until unless your application is running. once application is done, a Spark session is not a Spark session. Everything like for your application, resource manager is allocating the container, JVM. It is maintaining the history servers and all. Application master, everything will be getting killed. Everything will be out, including your Spark session. So that is up to application is running, and suppose application is running and in between only Spark session gets closed. Sometimes this also happens in real time. We get this kind of issue sometimes because of some reason Spark session gets closed in between. Then your application can't get complete. Your application will also get some kind of error that is also going to be failed. So this Spark session should be available with the entire application with complete life cycle from beginning to end.
While creating an application in Spark, we need to create a session. But
Yes.
to close as well, we need to provide the code to close the session at the end, or it will automatically close.
Oh,
Or it's a
okay.
good
So
practice to
if
close the session.
correct, we should close the session as a good practice. Okay. And the thing is, once your application is done, and this is not the streaming one. Let's say this is you have two kind of jobs in Spark. One is batch, one is streaming. In batch, let's say your application is this Spark session is getting fired after each 2 hour, just interval. Okay, so with each 2 hour, whenever this Spark session will get fired, this is again going to do the complete life cycle. Means this is going to create the Spark session, running in the job, doing all the activities, and finally completing that. Once this is complete, the entire JVM and all will get killed. Now consider for the streaming one. Streaming one means this is going to run continuously 24/7, right? In that case, a Spark session will not get closed. That is keep on running. If that is closed, then again you are going to face the issue, or it will get created. If you have managed that dynamically, in any case, that how you are going to handle this is completely up to you and up to your programming. But in streaming one that will be available, in batch one that will get closed, and every time this will create. Whenever this application is going to start with the Spark submit, every time this will get created. And of course, you should close it. Here, if you see, just I was writing one of the small code. So here I am trying to print the data frame. I am creating a Spark session. Then I'm reading a CSV file. Here in the input data folder, I have made one CSV file that is a very small data, ID, name, and location. Okay, and I'm just trying to read it. So Spark session is available. My file path is there, and then read the CSV file. Spark.read.csv. Spark is having multiple support for the different APIs, applications, packages, and all. Then CSV file path. This is the path. Header equal to true, infer schema true. We will discuss this later. Don't focus on this. And then df.show. Then spark.stop. So here I am going to stop the session whenever I am done with my job. So it will be providing me the output, and finally this will be closing the session. After this, if I do something, then it will say simply Sparks. Okay, let me print this again. Same line. Here you can see this is getting closed. And if I am doing this is df.show again after closing the session. Just let's see what is happening. This failed, right? Why this failed?
The session is closed and
Yes. So here this is printing for this one, line number 15. Then okay, this stop Spark context was created, and illegal state exception cannot call method on a stopped Spark context. Spark context is not available. Okay, because of that, this is going to be failed. Okay. So this is something about the Spark session. Now let me come back here. So while creating a Spark session, we can work with RDD data frame and data sets, and this will be available for that. Then Spark context. So Spark context is available since beginning version of the Spark. And in Java, if you are working with Java, then this is Java Spark context for Java, and for Scala, this is Spark context only. For Python also, this Python and R, this is Spark context only, and is used to be entry point for Spark and PySpark before introducing Spark session in 2.0. And creating a Spark context was the first step to the program with RDD and to connect with the Spark cluster. Now we are working with session. Its object SC by default available in the Spark cell. If you are working with the Spark cell, if you are not working there, if you are going with the IDE and you are writing your application, then you can create one object with SC. SC is the short form of Spark context. Then from 2.x version, whatever version we have from starting from 2.0, when we create the Spark session, Spark context object is by default. Like here, if you see the failure region, this is saying that Spark context is not available. But did we created Spark context? No, right? We had created a Spark session, but the Spark session is having all the things available. Either we are talking about a Spark context or SQL context, or if you are working with Hive, Hadoop and Hive, then Hive context, everything is available by default. So this is good to search internally and work with that. Then Spark context is by default created, and it can be accessed using the Spark.Spark context. If you want to work with this, then you can take up this. Let me copy this and see if that is failing. Spark context. See, this is available by default, right? With the Spark session. So you can do it, take it, and then let me take SQL. This is the SQL one, and Spark context is enough. Okay, so Spark context is available by default there. And then when we create just one Spark context per JVM, we can create many Spark session objects. Then we have three terms for the Spark. We are going to work with that with low level or high level APIs with RDD, DataFrame and Datasets. Let's take this example. For this RDD, we have the full form is resilient distributed dataset. That is a fundamental data structure of Spark, and it is the primary data abstraction in Apache Spark and the Spark core. Let's say when we are going to return the data as a data frame or data set, then we are defining that. But by default, if you're going with the low level APIs, then that is by default RDD with the Spark core. RDDs are fault tolerant, immutable, distributed collection of objects, which means once we create an RDD, we cannot change it. Each dataset in RDD is divided into logical partitions, which can be computed over the different nodes of cluster. Right? Like if you are submitting 1 JBF file and you are doing the partition, you are dividing into 10 partition. Then all 10 your data will be divided with the 10 different parts, split you can say, and each one will be working independently with different nodes, worker nodes, and finally output will be segregated at the end. Then RDD creation. RDDs are primarily in two different ways. First, parallelizing an existing collection, and secondly, referencing a data set in an external storage. Means if you have any file which data is coming from the source, you can create with that. And if you have some manual data you want to create on the fly, then also you can create using parallelize. Here
Oh,
I have to, yeah, go ahead.
sorry, now why it is fault tolerant?
You understand the concept of fault tolerant?
So like basically taking backup in other nodes.
Yes. So here also in RDD or data frame or data set, whatever you are working, there can be a condition that something get filled in back, and then how it is going to recompute, how it can recover the data, right? So RDDs, let's talk about RDDs only as of now. So RDDs in Spark, these are designed in backend to be fault tolerant. That means they can recover automatically from the failures. Let's say node failure happen or any hardware issue, or maybe a task got stuck in between because of networking and some data get lost between the nodes. In that case, Spark application will be your system will be good to recover the data. And how this works internally, whenever we are submitting any other job, then this creates a lineage graph. So Spark records the lineage in the sense sequence of transformation. Let's say here I am doing the transformation. Okay, let me go here. First I'm taking this file path. Then here I am trying to read. Maybe here I can have some filter, right? Here I can have some filter, then here I can have some join. So these are the different transformation. So for all sequence of transformation, this will be creating a lineage, and using that it is going to work with the RDD. And if any, let's say that RDD is having around 10 partition. If any, and all 10 partitions are working with different worker nodes. 9 are working fine. Somehow one worker node is down. Let's say that hardware itself is down, machine is down. In that case, that partition will not be available. What is now? You have 10 partitions for the file, 9 partitions are already working or maybe completed. For one part, this is stuck because of failure. And if one part is a failure, then do you think that this is going to produce the output? No, right? Because it needs the complete data processing. Until unless all done, this is not going to produce the output. So if any of the RDD partition is lost due to failure, Spark can recompute it from the original data or the previous RDD. Let's say this got that 10th partition got failed when it was trying with the join. That means prior to this filter was there, and up to filter this was perfectly fine. So it knows internally where was it and what happened. This will be good to recover the data from the filter. If it is not good to recover from filter also, this knows this DF step, because in the lineage it will be having all the steps. So this is having the DF, then it will take from here itself the first transformation. Okay, this is a transformation where I try to read the file, and then I did the later part. Then it will be recovering the data from this line number 12, and then again it will be working with the filter join for that particular partitions. So this will be recomputing from the original data, either original in case of all missed, or from the previous RDD using the lineage information. Like if you have RDD, let's say you are having RDD1, RDD2, RDD3. RDD3 is derived from RDD2 and RDD2 is derived from RDD1. And the Spark can backtrace to recompute RDD3 from RDD2 also. And if 2 is missing, then it can recover the data from RDD1 also. Okay, and if we talk about replication, like in Hadoop, we have replication, right? Replication factor by default 3. So Spark relies on data replication if input data is stored in a distributed file system like HDFS. If that is with HDFS, then by default HDFS functionalities will be working out. If you are working with S3 or ADLS or maybe with GCP, it's file storage, then based upon that platform, how it is configured, that you are going to achieve. So replication factor will be completely relying over the distributed file system, whatever you are using. And if you are working with HDFS, then HDFS is block of the data is replicated across the multiple nodes to ensure that data is not lost. And when we are triggering any of the action over the data frames, let's say RDD or data frame or whatever. So if any action is executed over the RDD, then Spark will recompute only the lost partition rather than the entire data set. Let's say this is for the 10th partition, it is unable to get it, that is lost. But 9 partitions are okay. When it is trying to recover the data using filter, using DF, this is not going to recover the entire data. This will be trying to first it will be getting the original data set. If this is not able to retrieve from the filter level, if this is going to the source, this will be getting the original one. And after that, immediately this will be coming back to the required partition which is missed, and it will be fetching the required data only. And again, recomputation is lazy in Spark. We discussed about lazy evaluation, right? This keeps only the references, and this will be happening only when required. Like lazy means, let's say this file path. This file is as of now only 2 lines are there, so this is completely fine. What if this file was 10 GB? I have copied a 10 GB file, and my system is not supporting with 10 GB. In that case, this will get failed. But when this will get fail, when I am saying spark.file path, this will not fail. When I am saying spark.read.csv, again this will not fail. This will keep the references like this is what I want to do, but this will not fail because this doesn't know what is the file size of the file. Either this is 1 GB or 10 GB. This knows only the file name and file path. That this is the file path, this is the file name you want to read. When I will be trying something, let's say I am trying for df.show or I am trying for df.collect or something, then this will fail because of memory exception, or maybe there can be some other errors. So this will be completely working with the lazy evaluation, which will be keeping the reference, but actually not working over the data until unless we are calling any of the action. Okay. So for the fault tolerant, this is working in this way, that if any partition of the RDD is lost due to node failure, then Spark will recompute it from the source file or from the previous step, previous transformation.
Yes, got it. So basically it keeps the track of it through data lineage.
Correct. Based upon the lineage only, this is going to work with all the steps. Otherwise, as soon as we are submitting any of the job, this is going to create the tag, and with tag it is having all the information. It's a lineage graph and all the stages and all. So this will be good to understand. And again, one thing can be, let's say if the lineage cannot be reconstructed, then there can be a condition where input data source got corrupted or missing, or we had did some cache or persisting, and we used it without the replication, and the cache partition is lost due to memory or maybe disk failure. In that case, Spark will be working again from the beginning, not from the middle level, and it will be starting recomputing from the complete step number 1, you can say. From there, it is going to start. Okay. Now we can be back here. So for RDD creation, this syntax I have copied from Scala. You can see val, var, right? In Scala, val and var is for mutability and immutability. Val means this is immutable and var means this is mutable. Okay, let me create with one of the example, and then we can go with this one. So this is the RDD operation. On RDD, we can perform two kind of operation. One is the transformation and one is action. This is for all dataset and data frame as well. So Spark RDD transformations are lazy operations. That means they don't execute until unless we are calling any of the action. And since RDDs are immutable, when we run any of the transformation, then it will be returning a new RDD on top of that. And when we call the action, then it will be returning the value from an RDD to the driver node. And in other words, we can say any RDD function that return non-RDD considered as an action. And when we are calling any of the action, then we should always avoid any of the action which is collecting the entire data to the driver node. So let's say you are having some 10 GB of data, and in Spark Submit, you are providing 6 GB to the driver node. If our code is optimized, really optimized, then driver node should not look out for much memory. Executor node we need the memory. You can go for 10 GB, 20 GB, 30 GB, whatever, based upon your data volume. But when we talk about driver node, then driver node is just to manage for your Spark application, resource manager, managing with the applications. But this is not going to work with the actual data. So it should not be looking out for much memory. It is minimum 2 GB should be fine. Maximum you can go for the 4 GB, 6 GB, 8 GB maximum. It is not. If that is looking for more than that, that means your code is not okay. You are having some issue with your code. You have did some random transformation which is not really optimized. Okay, like you are doing some collect. If you are doing collect, that means this is going to call out the entire data to the driver node. Is that required? No. If in some of the case, if you need, then make sure that this is the very small set of data. If you are trying for any of the purposes, then data should be very small. Or if you are trying for some sampling and all, then also, so try to do with the small sets of data, and if possible, you can avoid completely. So your driver node will be healthy in terms of memory, and do all the actual works with the um, worker node only. Always try that all the data is getting processed with the worker nodes, executors, and this is not getting overloaded with the driver node, because driver node will be only one and you are having set of machines, a group of machines. You can have 20 worker nodes, 30 worker nodes, 50 worker nodes. Then why you are overloading the driver node, which is the single one? So let it be free. So we should always care about that whenever we are calling any of the action, that action is perfect for the use case, and this is not calling calling all of the data or most of the data to the driver node. Then we have data frame. Data frame is a distributed collection of data organized into the named columns. Here you can see, if you look out the output, then kind of okay, here no column name. Let me go to this example. Here, if you see the output ID, name, and location. So this is completely coming with the tabular format where you have named columns, and then row wise you have all the data. Data has been converted to the structured format with row and column. It is conceptually equivalent to a table in the relational database or a data frame in R or Python. If you are creating Pandas data frame, then that will be always also similar to this. Only Pandas data frame will be having index number also 0, 1, 2, 3, 4. Here, if you look out this data frame, there is no indexing. Okay, you have to create if you want. And then data frames can be constructed from a wide array of sources such as structured data files, tables in Hive, external database, existing RDDs, or many more other sources. You can create it. For data frame creation, the simplest, yeah.
Srinagar, so can you please share your screen again? I'm not sure. So I restarted it, but it is getting lag. Maybe from my internet, but voice is everything is getting clear. The screen is little.
Yes, sir. Yeah, I'm also facing the same issue.
So
Lagging
screen is
issue.
getting free.
Yeah. So
Okay.
when we are switching from one to one, basically from PyCharm to PDF or PDF to notebook, it is getting freeze. Now also I'm not able to see a screen.
You are completely not able to say.
I just
Able to
rejoined.
see the
I,
PDF only.
Okay, let me reshare.
okay.
Is it okay now? Just let me know.
It's loading now from my side.
Okay.
Totally gray screen.
No one is able
Yeah,
to see.
totally gray
No,
screen.
not able to see.
Okay.
So can you? I think we have to restart maybe.
Just give me 1 minute. I will change it. Is it okay now?
Not yet.
Still looking like white.
Gray screen. So I think we need completely stop the recording and rejoin. I think it's gray screen. Yeah, now it came. Yeah,
It came. Okay.
now yeah, now the board is showing that all the team, all the members who have joined.
Yes, yes. I am on the same screen.
Okay. Everyone seeing that?
Yes.
Yeah, now able to see.
Now it's fine. Yeah.
Okay. So for this data frame, this is the distributed collection in the terms of tabular format, and we can read from variety of sources, several sources with the different formats, and it is having this is high level API in the Spark. So this is really very much rich for the supports with varieties of the data formats and all. And for creation of data frame, we can create the data frame either from the sequence collection or from the source files or maybe some other sources or maybe from the RDDs. Okay. For creating that, we have again, this is the example from Scala. We will be doing in the PySpark Python. Okay. Syntax will be completely almost same, a little bit differences between languages. Okay. Then this is the column name. Anyway, we are going to see this practically. And then we have Spark SQL. With Spark SQL, which provides several built-in functions, when possible, try to leverage the standard library as they are little bit more compile time safe. If you are going for the SQL one, which handles null and perform better when compared to the UDF. UDF we will be discussing. And if your application is critical on performance, then try to avoid custom UDF because UDF works with row by row and it costs with the processing time. This is going to take lots of time. So this is always not a good practice until unless you really need it. If that option is available with the Spark in that function, then try to leverage that. If not possible and that is the last option to create the UDF, then only go with that. Okay. So this is Spark SQL also. Let's discuss later. I will park it.
Also, one more question. So, do we use suppose in real life projects? I have not worked on. So I think you have worked on. So, what is the chances of using? I think most probably you are using DataFrame or Spark SQL. Do you use RDD also?
Sorry.
So, in real life projects, do you use RDD?
Yes.
RDD being
Yeah.
okay. So why use RDD if DataFrame is there?
Okay. There are lots of things to work with RDD. Okay. Well, let's say, see, some kind of transformations are there where you want to play with the data. Okay, so this RDD, what this data frame is, it is going to convert the data directly with the data frame API. Then you are working with the data frame, means selecting the column and doing some manipulation, completely table level, right? But let's assume that you are not looking for the tabular data. Your data is coming. Maybe data can be converted to table, but you are not looking for that. You want to do some kind of data manipulation without having in the data frame. Let's say you are getting some JSON and from that JSON you want to organize with some other models. Lots of requirements are there. Okay, I will share one of the use case, okay, with the JSON file where
Sure.
you will be getting some RDD, means you will be getting the exact picture why you are using RDD and in which kind of condition you are using a data frame. So there is no specific reason why you are using that. This is completely depends upon the requirement, what kind of requirement you have. And of course, you can do the same requirement with data frame also, but there can be a condition where RDD will be more better if you are dealing with that, either for the code level or something. Maybe you want to go with the raw Python code and you want to apply over the RDDs, or you want, let's say simple math and flat map. If that kind of requirement you have, of course, you are going with RDDs, right?
Yes, yes. Also because I read somewhere maybe 1 or 2 days before some documentation that they have stopped added it in maintenance mode. Maybe they will stop it something like that. Yeah.
Is it?
Yes, I'm not sure. I'll share if there is any link. Yeah.
I'm not sure because how they can do this.
Yes. Okay. Yeah.
Just a few days back, I heard that they are retiring their certification, some certification, Azure. Some I'm not remembering the name, but lots of certifications are there, right? So they are
Yes.
retiring some. Uh, Need to check the name, what the name is. But if they are retiring RDDs also, then in PySpark already they have excluded a data set. There is no data set, only DataFrame and RDDs are there. And I don't think that this should be, because RDD is having its own advantages. Lots of things are there to do. And if they are retiring RDD, that means whatever, like we discussed about when we are using Spark context for all the low level APIs which is not getting supported properly with the DataFrame, right? Then you are going to work with the Spark context. In case if they are retiring, then all that low level APIs and functionalities, whatever available for the RDD only, they will be migrating that back to DataFrame, right? They have to.
Okay.
Let's say map and flat map and all. We are working with the core RDD. If they are migrating, if suppose tomorrow RDD is not there, then that should be available with DataFrame. Then only we can work out. Or there should be some
Okay.
alternative.
So basically, you're saying we cannot replace already. I don't know. Yeah.
The requirement is there, no? If they are saying to replace, then they should give some option. Either make that option available to data frame, then I can work, or give some alternate, or migrate the same with the data frame. That should be there, because RDD is the requirement. We can't skip that.
Yeah. Got it. Yeah.
Okay, so let's say we are going to create the sample RDD. I'm just taking data equal to some list of data. 1, 2, 3, 4, 5. Again, as you asked, whenever we are creating the data, whenever you have this kind of data list and all, then RDD is the best choice for you to start with the data. Later on, you can create the columns and all, and you can convert into data frame. For this, you need to organize this data, right? So this will be much better. Here, let's say RDD1 equal to Spark context. So SC I'm taking. Here you can see SC is already available, and you have SQL context also if you want to work with SQL context. But again, this is not required, because if you see here, we have already SQL available with the Spark session, so directly we can work out. But in case required, you can take. So I'm taking SC. SC is a shortcut for the Spark context, and or let me create here SC equal to Spark context. Spark context, and I'm taking local, and then some name. Let's say like we give application name, right? So create RDD. Create RDD. Okay, it is okay. Here I'm giving SC dot parallelize, and then data list of numbers. Then print it. Print RDD for test. And RDD dot collect. RDD1 dot collect. This is the action we should always avoid, this collect one, because this will be collecting the entire data to the driver node. Here I can write sc dot stop, means I can stop the Spark context. Let me run it. What happened? A Spark context is not defined. Anyways, we are working with the data frame, right? Sorry, Databricks. Let me comment out.
By default, it should be there.
Yes. Let me see. Then I will run the same in my local machine. We'll see that. Failed. Spark context has stopped. Notebook will be automatically attached. Why it is getting stopped? Did I stop anywhere? Previously also nothing. Okay, I think issue is from this cluster. This one, this is already available, so it should not fail. Okay, issue is from this notebook. I need to create another cluster. Let me copy this to my local system.
Can you please create another notebook and try? I think this notebook was detached.
Yes, that's what I am saying. It is having issue. So I need to, or I can go here. We have option. This is saying connected, detach. Okay, detach and reattach. So it will refresh this. Okay, now it worked. So here we can see RDD for test 1, 2, 3, 4, 5. Now just let me, for testing purpose, I will run it again. And this is, if this is failing just for Databricks, let me test it. I will run it here. Spark context import. My spark.context. Okay, did not work. Cannot run multiple Spark context. We have multiples, of course. We have a Spark session also, right? Let me comment it out. Okay, this is working. So if you have multiple, because for the with the Spark session also Spark context is available. So that's why this will be getting failed. And here, if I go with this.
So basically, if you are importing Spark section, no need to import Spark context.
No, Spark context is available with this Spark session, no?
Yeah. So
All the things are bundled with that. That's why it will get failed. So this is not required actually, if a Spark session is already available. And here, okay, in Databricks, this is not supporting. Databricks, actually, we do not need to create anything in Databricks. Just simply start with your actual coding and work with it. Okay, so like this, we can create the RDDs RDD with an on-fly. If we want to create the RDD from the file, that also we can do. Like let's say here I have a file also with this location CSV file path. Let me uncomment. Then this one RDD1. I will create one RDD2. RDD2 equal to sc dot text file and then my file path CSV file path. CSV file path and then print RDD2 dot collect. Let's run this. Okay, so if you have data on fly, then you can create using parallelize. If you have data with the source file, you can create with this Spark context. Again, you can convert your data frame also with the RDD. So let me comment out all this. I will comment this completely and I will go with this data frame model. We have data frame and then df.rdd, simple, nothing else. Then print rdd1 dot collect. So we can create either with parallelize or here or with the source file, or if we have already data frame and from that data frame we want to convert into RDD and want to do some operations over there, we can do. You can simply write dot RDD, then that will convert your data frame to RDD. This has taken. See, this is row, and for each of the row, ID 1, 2, 3, 4, one of the list. You can see here. Again, this is for the second row. So it will be coming in the sequence. Now this is with the RDD API, and we can play around it. Fine. So we can create either with we can create a RDD with the three forms. One is SC Spark context dot parallelize to create RDDs from in-memory data. This parallelize dot text file to load data from the external storage, and RDD to convert the data from data frame to RDD. This one we can. Now we can create the data frame. For the data frame, you see here we have already I have created this data frame I am creating from the source file. So this is reading .csv dot. If I am having JSON, then I will be giving the option JSON, Parquet. Multiples are available. Okay. Here you can see if I'm typing the Parquet, it is coming with the Parquet. Then accordingly, it is having the JSON. So based upon the file format, we can take up. As of now, this is the CSV. So I'm taking CSV. And Then let's say this is the source data. I am creating the data from this one. Let me comment out this RDD also. I don't need it. Now, like RDD, we can create data from we can create data frame from in-memory data also. Let me take it the data, sample data. Data equal to, I am taking the data for each of the row. First row, then second row, and then let's take one more row, 3 row. For first row, let me take a name, Amit, and let's take age 25. And then let's take Ria 28. And then Ravi, let's take 24. This is the age. This is the sample data. Now what column I want? I want column equal to some name if you want. Then let's take name and second column let's take as age. Now I have the data and the column name which I wanted to. Need to create the data from this in-memory data. Then df1 equal to spark dot create data frame. Okay, create data frame, then data, then column. What column I want. And two brackets are not required here. Then print this df dot df1 dot so. Let me run this. Socket exception. Some connectivity issue is there. Anyways, I will copy the same to the database. I will debug it later. Where you can see Amit, Priya, Ravi. These are the coming with the name column names. Now just I want to test something. We'll run it again. If you see without name also means column name is not really mandatory. If I am giving the column name then that is considering. Otherwise, this is going with the default. Default is underscore 1, 2, 3, 4. How many columns will be there? This will be taking the default column name. Then later you have to rename in case required. So this data frame, create data frame is an function which is implemented with the args. This is arg1. Then args2, 3, 4. So this is the mandatory one. Okay. Remaining the next args are optional. Like when you were going through the Python, you see the default args, right? And either so some default args which you have to, otherwise this will be taking up either you are providing or not providing, that is not that is not really matter. Like yes, let's say column equal to you are giving the column. So either this is taking this one. So this is the mandatory one, and this is coming. If you are providing, then also fine. If you are not providing, then also fine. There is no impact with this. unexpected keyword arguments. This is the keyword argument, okay, column.
Should be schema equal to column.
Mm, mm, yeah, schema equal to. This will be double equal to only, right? Let's see. No, this worked.
This one.
Yeah. So this is means schema is provided while implementation with the default one. If you are providing, then also fine. If you are not providing, then by default this will be returning with underscore 1, 2, 3, 4, 5, whatever. So you can remove it now. So this is the data frame. Either you can create from the source file, or you can create it from in-memory data, or even you can create the data frame from your RDDs also.
So
If
the
from
data format should be in this format, like you are mentioning. In the list, there is tuple inside tuple rows. Is this the expected
this one,
format, or
this
yeah,
one.
this is the format you are mentioning.
Actually, I am taking a row, right? I need
Yes.
I need to define the row level data. So for each of the row, I have one of the tuple. This one.
Okay.
And all are the single file, single data. So this is list.
Okay.
So this is required. And then so data frame you created from file and from in-memory data. If you want to create data frame from RDD, that also you can. Okay. So for that, let's say we have already RDD here, right? This is the RDD one. And for that Spark dot parallelize, and we have this. Then create data frame. Same. Okay. So this is also RDD only, no? Whenever you are giving, this is the sample data. And this is going to work in the same way. Okay, just give me 1 minute. Let me check it. So this is data RDD. RDD equal to Spark. Let's say we have already Spark session. So Spark dot Spark context, and then parallelize, and then we can take the list of data which I want. So here I can copy the same. I will comment out this data frame one. I'm giving this. These are the 3 row. Something wrong. This bracket is for this. Then this is for this, and then finally, yeah, this is correct only. Bracket is fine. And then we can say df equal to it is like similar only. We are not going to take this is coming with this Spark context parallelize, and so this is now RDD. Let me just print it just to verify. RDD dot collect. Just to verify, yeah, this is the RDD, and now we can convert it. So df equal to Spark dot create data frame, and then RDD, then df dot show. Yeah, this is okay. So like this, we can create with unfly data where from the file, an external source, an external file, or maybe if we have any RDD which is coming with the Spark context using parallelize, we can first take that input data and then finally we can convert that into data frame using create data frame. Then
In
we have,
RDD, we cannot mention schema.
we can, let's say if I have the schema, we have column name, right? Sorry, above I have created column. This
In
will be
RDD.
working.
In
Yeah,
RDD. No, we have given, you have given in data frame.
data frame.
When we are
Yes.
creating RDD through
No,
parallelize.
no, 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 no.
Okay.
That is not a named column or row column, right? If you have a column here, then column name, then that will be coming as a record, not as a column name. It is
Okay.
not converting the data into structure format, no?
No, so only data frame is a structure format. RDD is
Yes,
kind of messy. Yeah. Okay.
yeah. Now, data set in Scala. So data set is not available with the PySpark, right? In PySpark, we have only RDD and we have only data frame. If you want to go with the data set, then we have to skip. Here only you can skip with the Scala, then language will be completely Scala. You can change. Now I will comment the entire one. And we can work with Scala. So for Scala, Spark session will already be available, but I am taking val Spark equal to Spark session Spark session dot builder and then dot app name dataset test, and then let's say I'm giving master also. Anyway, this is not required here. We are working with only single node cluster, but I'm giving this master local, and for any of the node, let's take star and then dot get or create. Get or create. So this is the Spark session. Now I will do import Spark dot implicits dot underscore. So it will be taking all. Now defining a case class. So in Scala, this is the comment. For comment, you have to go with this slash. Then define a case class. Here, let's say I want to create the data set for the employee. So case class employee. And what I want, I need a name, and the name type would be string, and then I need let's say age, same data as we took above, and for age I need data type as integer int, and then here first our case class is created, then we can get the actual data either with unfly or with in memory. That is not an issue. So let's say I am taking this data only above one we had created, right? So let me copy the same data. Well, data equal to Well, data equal to, here I need to give case class name, that is employee. Employee, and then this again I need to give the same. Employee, let's take 2 records only. Okay, and I will take it as sequence. Anyways, I can try out if this is working, then later. If not, then later I can change it. Then creating the data set. Create data set and val ds equal to Spark dot create data set. Create data set and data. Then ds dot show. So just like create data frame, we had for the data frame, for the data set, we have create data set. Just let me run if this is working fine. What is the error? The error is illegal start of data impression. Yes. So let me give the sequence. We'll take convert into sequence and then we'll change this as well. And this will also get changed. Now let me run it. What is the reason now? Error not found Spark session. Okay. Let me import. Import org dot Apache dot Spark dot SQL dot Spark session. Now let me run it. Again issue. Value implicit is not a member of Spark frame. Spark dot implicits. Spelling is correct. IMPLICIT. Spelling is wrong. Yeah, spelling issue was there. Okay. Now before checking to the output, I will just check with this if this is working same for data set as well, like DataFrame and RDD. Yes, so Spark session is not required. I am taking this Spark implicits and then for this going with this. So you can see this has created this DS data set where data set is employee, and for employee we have name and string, and for that we have the data. So like this you can create the data set. But anyway, this is not available with PySpark. But if you are working with Java or Scala, then this data set will be in the picture and you have to work with it as per requirement, because this is much optimized. This is the combination of DataFrame and RDDs both. So optimization wise and means internal optimization without having any additional thing, and many more things are there, which is really very much helpful for your implementation and dealing with a good amount of data with some critical logics and all. But if you are working with Java and Scala, then only this will be, otherwise it's not in the picture at all. So let me comment it. I can back to Python again. And in that case, I will I will be back to the previous code. Okay, so this is just about creation of RDD and data frame. Then next we will be discussing about the next part of this, like header and info schema and all, along with some other details. Anyone has any question up to this, or any point, any input, anything?
So now, so from the architecture part, what kind of question may come? Like what is legibilization, drivers?
Architecture part, you can have a simple question if you can explain a Spark architecture. This is the very common question for interview. Okay, like I showed you this slide, right? If you can build understanding about this, you will be good to explain. And again, tomorrow, maybe tomorrow, with our real time practice only, I will be adding one real time use case here, how this is going to work. So if you can explain this cluster wise, how this executor, task, driver manager, cluster manager and all. So this is about your Spark architecture, how this is going to work. Now Spark application. Have Spark application, if you are whenever you are deploying any other application, have internally this is working. Then that will be working on top of this architecture, right? Because this is just the hardware, nothing else.
But
On top,
they go to deeper level or just like we'll say cluster machines, the one will be driver node, one will be worker nodes, and
this is
there will
the
be
Spark architecture, the hardware level you can say. This is
okay.
the cluster. Okay, this is hardware detail. Now, if someone is asking, okay, when you are running any of the application, how this works internally, then that will be taking you in the terms of DAGs and lineage and graphs and
Okay, got it.
exchange and tasks. So question will be there. Question can be either Spark architecture. If is Spark architecture, then you can explain end to end, including all the things, whatever you can explain. And if question is coming with what is DAG or what is questions are there. People used to ask what is DAG, what is staging, what is task, and what is lineage graph. These four questions can be. Apart from this, I don't think that any questions will be arises.
Got it. Got it. Yeah.
Okay, fine then. Let's meet tomorrow for the next step. And today I will add you for this document access. Okay, and even I will share one small exercise as well for creation of data frame, data set, and RDDs. You can try out.
Thank you. Thank you.
Yeah. Have a good day. Bye.
Bye.